Alright, so I'm going to be doing problem 39 from the chapter 5 homework. And the problem reads, a 3 kilogram block starts from rest at the top of a 30-degree incline and slides a distance of 2 meters down the incline in 1.5 seconds. Part A says to find the magnitude of the acceleration of the block. Part B is to find the coefficient of kinetic friction between the block and the plane. C is to find the friction force acting on the block, and D is to find the speed of the block after it has slid 2 meters. So the first thing I did was I just drew a diagram. So here we have the 3 kilometer block at the top of the incline. At 30 degrees, it slides down a distance of 2 meters in 1.5 seconds. Next, I drew a free body diagram of the block. So in the y direction, we have the normal force going up, always perpendicular to the surface. Then we have weight going straight down, which I split into x and y components. And then acting in the direction opposite of motion, we have the frictional force, which is the coefficient of friction times the normal force. And to make things easier, I had my coordinate system rotated. So part A can actually just be solved with a kinematic equation. X equals v initial times time plus 1/2 acceleration times time squared. V initial is 0, so that cancels out. And then solving for A, you get 1.78 meters per second squared. Next I did part C before part B. Part C is asking for the friction force acting on the block. So what I did was I summed up all the forces in the x direction. So in this picture you see we have mg sine theta in the positive direction, and the frictional force is acting in the negative direction. So mg sine theta minus the frictional force equals the mass times the acceleration in the x direction. And then solving for the frictional force, we get 9.36 newtons. I did part B after part C. Part B asks for the coefficient of kinetic friction. So first I summed up all the forces in the y direction, which is the normal force acting up and the mg cosine theta acting down. And because the block has 0 acceleration in the y direction, you can change the equation so that the normal force is equal to mg cosine theta, and you can solve for the normal force to get 25.46 newtons. Now we have the equation of the frictional force equals the coefficient of friction times the normal force. We need the coefficient of friction, and we have both the frictional force and the normal force. So by changing the equation to solve for the coefficient of friction, we get the answer to be 0.368. Lastly, for part D asks for the speed of the block after it has slid 2 meters. So again, this is just a simple kinematic. I used velocity final squared equals velocity initial squared plus 2a times delta x. Again, the block starts from rest, so v initial is 0. And solving for velocity final is 2.67 meters per second. Thank you for watching.